Okay, guys. So this is just a couple notes and to go through a couple more examples. So when waves travel through a medium, it is likely they will cross paths with other waves. Interference occurs when two waves pass through the same place at the same time. The principle of superposition predicts the new shape and amplitude of the waves when interference occurs. And then we already have drawn our example of constructive interference. This isn't in your notes, but that's why we put it in our other ones. Now, that example was when the waves were the exact same. What if the waves are different? Well, the principle of superposition states that the amplitude of the combined waves at each point of interference is the sum of the amplitudes of the individual waves. Now, if you have different color highlighters or different color pen, take that out right now, and we should draw in the different colors so that you can actually see them on your diagram as they are here. So say we have pulse A or wave A coming in and we have pulse B coming in. So they're actually two different sized waves. Now as they meet, this is the region of pulse overlap. So this is going to be the actual wave when those two meet and come together. The original position of A is right here, okay, in the red. And the original position of pulse B is right here. The one that's on the top is the result. That's the one that you should just make sure you can see, that that's the one that results. That A and the ones underneath are just showing you, okay, that's what A and B were at, but they combine together to make this overlapping bigger one. And again, here we see the same one, but it's just showing us as the wave is traveling through. So here we have, this is the resultant wave. Here is pulse A, and here is pulse B. I should have drawn those in those colors. Okay, and then again here we see, here's our result. A, and here's the B. The main thing I want you to get from this is that the two add up to make the bigger one. So this is constructive interference. So it's not necessarily doubled, but it's whatever those two waves are added together. Usually the amplitude of crests are positive and the amplitude of troughs are negative. We just set those to positive or negative. When the two waves overlap and the amplitude of the resultant waves is greater than the amplitude of the individual, this is known as constructive interference. When crests from two waves or troughs from two waves overlap, the waves are in phase and will produce constructive interference. Okay, and then you can turn your page around. So when two waves overlap and the amplitude of the resultant wave is less than the amplitude of the individuals, this is known as what? Yeah. Destructive interference. When a crest from one wave overlaps with a trough from a second wave, the waves are out of phase. This was what you were trying to say, Dylan, that they were out of phase.
That's his word.
Yeah, and produce destructive interference. And we already drew in our diagram of destructive interference on our other sheet. So now you have this picture of a little analysis of different size waves. So let's just look at one of these diagrams at a time. So let's look at the left-hand side. Okay, so just looking at the left-hand side. So these are two different situations. So right now on the left-hand side, we're looking at constructive interference. And it's going through chronological order, starting with this one is happening first. So what we have is we have two waves interacting or coming toward each other. Now let's give these waves actual numbers to signify their amplitude. So let's say this wave has an amplitude of 2. And this wave has an amplitude of 3. Okay, I'm going to write that in here too as well, 2 and 3. They're coming closer together. Now when they actually meet and produce that larger wave, what number can I attribute to that larger wave? 5. See, you guys are brilliant. Okay? Now when they pass by each other, the number 3 wave is still moving this way. So this resultant wave moving to the left still is again 3. The one moving to the right is 2, etc. So after they pass by each other, those waves maintain the same amplitude. So now on the right, we have destructive interference. So let's give these numbers too. So the one coming in, moving towards the right is 2. And this one moving towards the left, we're looking just at the trough interacting. And let's give that a -3. And we give it a negative since it's the trough. So again, here we have the 2 and a -3. So now when the crest of this wave and the trough of this wave actually meet, we are going to have a value of what? -1. And that's why it's still a trough, okay? Because it's a negative value, meaning that it's a trough. And we can attribute -3 to the wave moving to the left and 2 to the wave. And there's a trough missing on your last diagram here. It got cut off. So draw that in. So obviously you can see the differences between constructive and destructive, I hope.